In part 4 of the P3 Algebra Series 9709/32, we learned partial fractions from first principles. In this lesson, which is the first of the two lessons on partial fractions, we are going to learn why partial fractions exist, the distinct and repeated linear factors, substitution method, equating coefficients, and a few exam shortcuts. Next up, we are going to do quadratic factors, improper fractions, and then full exam questions. Now, if I gave you 2x minus 13 divided by two linear factors, let's say 2x plus 1 over x minus 3, will you be able to instantly turn it into 4 upon 2x plus 1 minus 1 upon x minus 3 without expending anything? Today I'll show you the fastest marks in Pure 3, so stay tuned. Now, in O levels, we used to combine fractions. Today we are reversing the process. So instead of combining 3 upon x plus 3 plus 4 upon x minus 2 into one fraction, we are going to take one complicated fraction, for example 3x minus 2 over x plus 1 times 2x minus 3, and we are going to split it apart into something like a upon x plus 1 plus b upon 2x minus 3. Now, you may ask that in the preceding lessons, why did we spend a whole lesson or a whole 40 minutes finding factors in the factor theorem, right? Because before we split this thing, let me change color. So before we split 2x minus 13 over x squared minus 5x minus 6, we must factorize x squared minus 5x minus 6 into x squared minus no, sorry, it won't be that. So this is going to be minus 6x plus x minus 6. So this becomes x minus 6 plus 1x minus 6. So now we can rewrite it as 2x minus 13 over x minus 6 and x plus 1 and x minus 6, and then we can break it down into two fractions with linear factors in the denominator. So now let's do case number 1. Case number 1 is distinct linear factors in the denominator. Okay, distinct linear factors. Now let's do a textbook example here. It is given there that 2x minus 13 over 2x plus 1 times x minus 3. So we can rewrite this as a upon 2x plus 1 plus b upon x minus 3. Now, what we can do is we can multiply this entire equation here and here by this highlighted denominator on the left, right, in order to get rid of it. So we are going to have 2x minus 13 is equal to a times, because this 2x plus 1 is in the denominator, so in the numerator this 2x plus 1 times x minus 3. So 2x plus 1 and 2x plus 1 is going to get cancelled, so I'm going to have a times x minus 3, and similarly I'm going to have b times 2x plus 1 here. Now all we need to do is we have to, so let me introduce substitution here. All you need to do is pick those values of x here, because we have got two unknowns here, so let's pick two such values of x which are going to eliminate one of the terms, right? So if I pick x is equal to 3, that's going to eliminate this one, and if I pick x is equal to minus half, this is going to eliminate this one, right? So let's do these one by one. So now first of all, if I take x is equal to 3 and apply it throughout in this equation, so this is going to become 2 times 3 minus 13 is equal to a times 0, because 3 minus 3 is 0, plus b times 2 times 3 So 3 into 2 plus 1 is 7. So this is 6 minus 13 is negative 7 is equal to 7b. Therefore, b is nothing but negative 1. So that's our value of 1, right? Value of b right here. Now, in order to eliminate this one and find the value of a, I can put x is equal to, I can substitute x is equal to negative half. So now this becomes minus 1 minus 13, which is minus 14 is equal to a times minus 7 upon 2, which is minus 3.5. So this becomes minus 14 is equal to minus 7 over 2a. So minus minus gets added. So a becomes 4. So we can rewrite this fraction 2x, which was 2x minus 13 over 2x plus 1 times x minus 3 into as a upon a is 4, 2x plus 1 plus b, which is minus 1 now, so minus 1 upon x minus 3. And now what you can do and how you can verify it, you can take the LCM on the right hand side and prove that it lands here as a single fraction, which is on the left hand side. So Cambridge students waste time expanding, right? So you try to expand the denominator and try to do all sort of gimmicky work, but that doesn't work here. All that the examiners wants you to see is that when x is equal to 3, it kills a. As we saw here, when you took x is equal to 3, it killed a, and when you took x is equal to minus 1 halves, it killed b. Now this is our second, so this is our case 2, in which we have repeated linear factor. Okay, so now let's say that you have instead of us having 2x minus 13, so 2x minus 13 upon, we previously in the last question we had 2x plus 1 times x minus 3. Let me say that now we have x minus 3 whole squared. So now we are going to have 3 fractions. So this could be, one fraction was a upon 2x plus 1, we don't know. The other would have been b upon x minus 3, and the third would definitely be x minus 3 whole squared. Now there is a possibility that b becomes 0 and this doesn't exist, but nonetheless there is a possibility, right? Because when you take LCM, so if you have 5 times 7 times, so let's say if you have 1 upon 5 plus 2 upon 7 plus 3 upon 49, so while the LCM is going to be 49 times 5, nonetheless there is a possibility that there is another factor here with a denominator of 7, right? Therefore we cannot eliminate the possibility of this here. Now we repeat the same process and we multiply this entire equation here and here by the denominator on the left hand side. So the left hand side is going to become 2x minus 13, and this is going to become, so a gets multiplied with this entire denominator of the left hand side, so it is only left with x minus 3 whole square. Now b becomes, when it gets multiplied with this, so 1 x minus 3 factor gets cancelled, so it is left with 2x plus 1 and 1 x minus 3. And now c also gets, this third term also gets multiplied by the entire denominator on the left hand side, so x minus 3 whole square gets cancelled in the numerator and denominator, and all you are left with as a coefficient of c is 2x plus 1. Right now you can start substituting values. So I would first take x is equal to 3, then I would take x is equal to minus half, and now because I do not have any other factor producing me a value of x such that it gives me it turns the bracket into, or it turns a factor into a 0, therefore I am going to use a trivial case, which is x is equal to 0. So now let's see what happens here. So when I take x is equal to 3, this gets eliminated, this gets eliminated, and I'm only left with this. So this produces a negative 7 here, like in the previous example. And for c it becomes 2x plus 1 is 7, so this is 7c, so c is now negative 1. Pretty straightforward. Now when I substitute x is equal to negative half, this cancel, this eliminates b, this eliminates c, and I'm only left with a. So this makes it minus 14 equal to, and right hand side is going to be minus minus half minus 3 is minus 7 upon 2, so a times 49 upon 4. So this becomes what? 7 times 7, 7 times 2. So negative 8 over 7. So negative 8 over 7 is going to be the value of a here. Now, in the last case where x is equal to 0, I'm going to use the values obtained for c and a, and I'm going to see what happens next. So when I apply x is equal to 0 throughout in this equation, what I'll get? I'll get minus 13 on the left hand side. Let me put a margin here. And a times minus 3 square is 9a, and so is equal, so minus 13 is equal to 9 times a, which is minus 8 over 7, plus b times 2 times x is 0, so b times 1 times minus 3 is negative 3b. We are doing this in order to get the value of b as well, right? And plus c times, so plus c plus c times 1, which is minus c. C is minus 1, so this is nothing but minus 1, right? Now, what do I get? So this becomes 3b is equal to 12 minus 72 over 7, which is 84. So this becomes 12 over 7 is equal to 3b, or therefore b is equal to 4 upon 7, and that's the answer. And now we can rewrite this entire expression of 2x minus 3 upon 2x plus 1 times x minus 3 whole square as a. So a was negative 8 over 7 times 2x plus 1 plus b. b is 4 upon 7 plus b upon 7, and we had put x minus 3 here, so we'll make sure that we do the same because we used this structure in order to obtain values. So now under b we cannot really write x minus 3 whole square. That's going to create a disaster here, so we don't want to do that. And c is minus 1, and under that we had x minus 3 whole square. So we decomposed this messy fraction with 3 terms or 2 linear terms, of which one was repeated, into a sum of 3 fractions, right? Now, so substitution just makes doing this quite faster. Now, a very important examiner trap is if you miss this term, right? So while decomposing this partial fraction here, this entire case here, if you, because more often than not students miss to put this because they are in such a hurry and they want to obtain all the marks, they just miss this one, go ahead and get all the wrong values for a, b and c, and hence not getting a single mark out of 6 marks which were just, you know, offered for free, right? Now, what the common mistakes in this topic are that you are missing the repeated denominator, or you create a wrong decomposition structure. For example, you put this structure up, found the values of a, b and c, and then while you're substituting them back, you confused b with c, right? Don't do that. And the third trap or the third mistake that students usually make is that they're not multiplying the entire denominator, right? You have to multiply this entire thing with this one, and this one. This is just cross multiplication. So for example, if you have 2 upon 3 times 7 is equal to a upon 3 plus b upon 7. So what are you going to do? You're going to multiply this 21, which is right here, to cross multiply. So this is going to become 21 upon 3a, which is 7a, plus 21b upon 7, which is 3b, right? So this is similar to that, right? So you have to multiply both the factors here with this term, and one denominator is going to get cancelled that way. And number 4 is if you're expanding too early. So if you have, so imagine what would have happened if you expanded this x minus 3 whole square into x square minus 6x plus 9, and then further multiplied this by 2x plus 1 in order to get a cubic polynomial in the denominator. I mean, that would have been a disaster, right? So don't do that. In the next lesson, we are going to do a case 3, which is going to have, so for example, what if you have a 1 upon x square plus 1, which is a quadratic factor, and x minus 3, right? So how do we decompose it? So this now is going to become ax plus b upon x squared plus 1 plus c upon x minus 3, and we are going to explore how you do that. And then case 4, where you have improper fractions. So what if you have a quadratic factor here, x squared plus 3x minus 8 upon x minus 3 and x plus 1, and then how are you going to do that, whether you're going to introduce a constant as well or what, right? And then we are going to see in the next lecture, towards the end of the next lesson, that how partial fractions connect with binomial expansions, which is our 6th lesson out of the 6 lessons in the series of algebra, which is the topic 1 for P3. So now this is one of Cambridge's most favorite combinations. We go by the name of Easy Talim on our Instagram, so make sure that you are following us there and drop us a DM if you follow us there. And if you have any queries, you can reach out to me without any charge on +92329 on my WhatsApp 3028 485. I'll see you guys in the next video.